on the Zoom or anybody else that is not available. So welcome. I'm Craig Jones. I have one of the legacy Mavericks, which is back there that Dave is kind of working on, and that we will be demonstrating, or I say we, but I really mean Vince, is going to be demonstrating his program and also his holder for holding the dovetails and a variety of different joinery that he can do on that machine. I've been at it for about 10 years approximately. I do a lot of lighted signs, edge-lit LED signs. I do other kinds of signs. We do a lot of plaques. And the one thing we'll be talking about the show and tell in a little bit, and I'll show some of the things that I've done on the turning center for the Maverick. So with that, Mark, tell us everything we need to know about Mark.
So I'm Mark Moore, and I'm primarily interested in cutting things apart so that I can glue them together in novel ways and put them on a lathe. That's kind of the driving problem for me.
And he's got some examples over here of little puzzle pieces that we carved.
In my mentorship section, I cut puzzle pieces out that I glue together and use to form the bottom of a platter.
Are we going to see them be able to be put together?
Not tonight.
Oh,
okay. Never do a demo that you haven't done offline first.
I learned that way back. Yeah.
I'm Tracy Whalen. I've been with the Guild for about 3 years. And I have a Pacific Tooling 6012, which in other words, 600 by 1200 millimeters, 2x4. And I've had that machine since 2018. Wow. So I've been playing around. My forte that I like to do mostly is artwork. And it's inlay.
Hi, I'm Steve McGowan, and I have a tiny 10 by 10 inch CNC router a friend built, and I've been using it to make cutting boards and basically various small projects, boxes, and things like that.
Steve also, well, I'll let you do it on show and tell to show your dust collectors.
I'm Bruce Dorr. I've been CNCing, I guess, now for 6 or 8 years. I've got a Sharp. I mostly do small boxes, little art things, nowhere close to what Tracy does, but and some inlays that are fit on a small box. Yeah. And birds. I'll show you some birds.
The Birdman. All right, one of several. Yeah.
My name's Tim Carell. I have nothing and I know nothing. This is my first SIG meeting for CNC, and I'm here to learn. So okay. I'm just going to listen.
Great.
I'm John Davis. I also have a laptop and want to learn CNC. I do have some background in CAD. So
what kind of CAD?
SolidWorks and AutoCAD.
Okay.
Steve, SolidWorks, already done?
Already.
Hi, I'm Rich Bader. I've been a member of the Guild about 2 years. I've got an Avid CNC machine at home. I've made some signs. I've made some birds. I aspire to make some Japanese joinery.
Hi, I'm Dave Smith. I've been in and out of the Guild for several years, since 2016. I'm on my 4th CNC. I started with a Shark. I've had 2 legacies, and now I'm using a long mill.
set up in my apartment along with my laser. But interestingly enough, it doesn't make enough noise to disturb the neighbors, and so they don't know what I'm up to. Anyway, anybody else?
Okay. And one more person that needs to introduce himself so that we have the hybrid meeting.
Yeah, I'm Bland MacArthur. My CNC doesn't have a gantry. I'm the gantry, but it's got an infinitely large bed. It's called a Shaper Origin. So I can make anything as large as I want.
Oh, perfect. Okay, let's ask our Zoom folks to introduce themselves. We could.
I'm Julie Niemeyer. I'm your guild registrar amongst other roles that I dabble in. I take this hat off and put the other hat on. And I joined the CNC group to ask them to take on the Comfort Bird project, which they are really running away with. And interestingly enough, they hooked me. I don't have a CNC machine, but I took their class and I can't stop thinking about the possibilities here. So John and Tim, I was with you. I'm started out like you and thought they were speaking Chinese when I was at that meeting. So yeah, this is one of the fun times that I spend on a Thursday evening once a month. So I look forward to meeting with my mentor, Tracy Whalen, in April to develop my own project on the CNC machine. So you guys
Great.
hooked me in there.
Well, thank you very much, Bird Lady. So we've got bird men and bird ladies. So, you know, we're not sexist here at the Guild. So, you know. Oh. How many birds do we have?
We have Frank and we have Marty.
How many birds do we have?
Oh, I'm sorry, I didn't hear you. Right now, personally, I have over 100 birds, and most of them are from the CNC group. Larry Wade has about 75 birds, so we're running away with this. Our goal is 150 birds for the gathering of the guilds, and then another 500 for giving away to a variety of social services after that.
Okay. Great. On those birds that you have, are most of those finished, sanded and finished, or it's still in process?
They are still in process. Most of them are still in the sanding stage. Like I said, in April, we're going to get together with the women's special interest group, and they've agreed to learn how to finish. So the women's special interest group is not exclusively just for women. I would like to invite everybody that would like to learn how to learn the process of polishing. These are not it's not an applied finish. It's an actual wax polishing system that is much more durable. It doesn't set on top of the birds. It's actually polished into the wood. So years ago, or I shouldn't say years ago, but it's the same process that pipe makers used to finish pipes. So
okay. On the sanding, is that done with little pieces of sandpaper, or is that automated, or how is that done?
Well, actually, Rich Bader is the one that brought it to our attention. Sanding star mops that are a I should have brought it. This evening.
Sanding mops. Yeah.
Yep, and maybe you are all familiar with that, and they come in different grits. So we're using those quite successfully. And then the Abernet product of, it's a Mirka product actually, of sanding strips, sandpaper strips that come in different grits. Those are very successful as well.
Great.
But-
Thank you. Okay, we'll look forward to many more of us becoming bird people. There you go. Got to use the right wording. Okay, Frank, can you introduce yourself, please?
My name's Frank. I have a Axiom 2x4. I haven't been doing much of anything during this cold weather. It's just too cold out in my shop to be out there doing anything. But I do signs, plaques, commemorative stuff, and pretty much anything that I can come up with.
Okay, well, thank you very much. Did we have Marty? Let's see. Did we have somebody else?
Yeah, this is Marty here. I have laryngitis and I'm zooming in from this top floor of St. Vincent's today. You can call Julie the bird lady and I'm the bug lady because I have some kind of crud. I'm really excited to be part of this. I got into the woodworking thing through Larry and hand carving, but I have a son who's a mechanical engineer who loves to build stuff with computers. And I feel like this is going to be an opportunity for us to do stuff together.
Great. Well, welcome. And we're glad that you are Zooming in as opposed to sitting here with all the rest of us. So thanks for Zooming in.
Thanks.
Oh, and by the way, Marty is on the top of the list for the next Zoom class.
Oh, yay. Okay. Well, thank you everyone for the introductions. Now let's get down to business. We are waiting for Vince to come back. He is the one that's going to be presenting his software to do a variety of different jointery projects, specifically on the legacy machine, the Maverick, the bigger one. But let's talk about kind of a show and tell. I think that we've got a few different things to show. I brought in just a couple things that I've done on the Maverick. Basically turning, and this is kind of just a little sample of some of the things that can be done on the machine. The turning, the rope, and also one of the things that, you know, people with a lathe, I suspect that they probably could do the rope molding. I know that I don't have the expertise to do it, but I can do it on my machine. The one thing that I think a lathe person would really have a problem with putting lettering around a spindle, and also maybe some problems doing a carving around a spindle. So that's something that because what we're doing is we're turning the piece slowly and letting the router do the work, do the carving. So I'll pass this around just as kind of a little sample. And I also have my gavel, which, you know, I hadn't thought about this being a gavel, but, you know, it's a cane that I made exclusively and completely on the turning center. The turning center does turn round pieces, and it also will do indexing. So index, carve one surface, rotate it 90 degrees, carve the next surface. And you can see that instead of just the 90 degree, you can set it to almost any degree that you want. and it will turn and do the carving. You bet. It's dangerous, big danger. So anyway, this is just a sample of some of the things that can be done on the machine. There also is a little spindle that is physically mounted to the machine, and you can take a look at that. It's basically a turned piece that has a through carve in it. It's interesting. Don't hit anybody. Okay. No promise. Yeah. Promises, promises. Let's see. I think we have a couple more samples or examples of some of the things that we can do. Why don't you go ahead and show us what you've done, Steve? Here, you'll want to use this.
Okay, so
Just for the
Oh,
camera.
okay.
That's all.
but these are models I made using SolidWorks, and they're all just most of them are single layer. This one actually has 3 different depths to the background. The surface is all the same depth, and I think this was I just find patterns on the web, and a lot of these are tattoo patterns for little things, and so and then this one I was just experimenting with a 1/32 router bit, and seeing what kind of detail I could get, and 4 hours. Most of them are these about 3 or 4 hours. And then this one was a tattoo pattern, and but I was sort of looking for Celtic knots kind of thing. And then this was more of an Oriental kind of theme, and then this one here I found a what do you call it, a mariner's compass, and so it's hard to see, but I made it. I made a model of it, and basically it's got like about 5 different files I generated, because each file is a different depth, because I could only do 2D path generation with the program I had. And then I also got a copy of VCarve, and I used that to cut all the lettering in around it. And so anyway, but this one was a lot of work, because it was just a matter of coordinating all the files and doing them in the right order and stuff like that in order to get it done. So, but
Pass it around.
yeah, sure.
Do you want to show your dust collector?
Sure. Yeah. Can we do it on the machine, or?
Yeah, when we come over, we can maybe do it. But
So
so this is done with VCarve, right?
no, this is SolidWorks. And
okay.
What do you call it? Someone gave me an example of one of these things, and so I made, from the physical model, I made a parametric model, and it's, but I changed the geometry of it so it will basically stretch underneath, and it goes in. There's no room on that router, CNC router, to have the hose go down the side, so it has to come out the front. And so, but that meant that I had to make the shoe sort of stick out. So in any case, this takes 21 hours to print, and probably about an hour to assemble. And then I also printed this little adapter, which fits on the top of this. And it just twists on. It's a wedge, so it locks on, and the other end goes to the hose on the fine backs that we have here for the dust collection. So, what? Oh, yeah, yes, all right. The comment was is that the previous dust collector under Legacy was probably 4 times the size of this thing, the size of the shoe, and it didn't do as good a job of collecting dust as this little one does. And so anyway, so I've made a second one for the second machine. That might have cost me or so. Anyway. I went on the web and I kept looking for various, brushes, and I found this thing, and this is for garage doors. And so you buy it by the foot from a, company, and what is it? Problem is, it's shipping's kill you on the thing. So like $12 and then another $8 for the shipping, right, to get it. So anyway, that's how I did the brush. So.
Okay. And one of the really neat things, and you can take a look at it on the small Legacy machine. It's got a magnet, and this can slide up and down. One of the problems that everybody has with dust brushes is that, if you've got a short bit, fine. This goes right down on your material. If you've got a long bit that sticks down below it, it just throws sawdust every which way, where this can slide up and down. So basically you can adjust the height easily. You can adjust the height a little bit on the other dust collectors, but it's painful to do it. And it's still maybe up to 75, 80%, maybe. But this one is amazing how efficient and effective it is. Anyway, so you'll be able to see it on the small machine right now, on the big machine as soon as we get a bracket in for the thing. Okay. Whoa, yeah, this way. You want to show off your, nope. Oh, the birds have flown the coop. Uh-oh. Okay. Did you have some? Yeah, why don't you come up here so that the camera is available. Yeah. Oh, the whole flock of birds.
Oh, my goodness.
These are from the model of Vectric, the free model Vectric has. Two-sided carve. And they take me about an hour, I guess, type thing. So throw one on, mess around the shop, do okay with it. I finished them with the armor seal and applied with 400 grit sandpaper, so it gives a pretty nice feel to it. So anyway,
Talk about the wings.
I showed them last time, but I've also played with making them two-tone. So the Vectric software calls, or the model calls for 1.5 inches thing. What I do is these ones happen to be 1.25 inches, and then I laminate an 1/8 inch on either side and then carve through that. I'm thinking probably it'd be better with a 1/4 inch, which would make a little bit bigger wing, but it really gives an interesting effect. And also you can use.
So that way they fly a lot better, right?
Absolutely.
With bigger
It's
wings.
streamlined.
Yeah.
Anyway,
okay.
Kind of a cool effect. Right. I don't know. I'll pass the bag around if you want to.
Yeah, just kind of look at the bag. Yay! All right, Tracy. Yeah. Ooh. Oh.
Okay,
All right.
first off, I have about 18 birds in my little bag over there that I'm giving. So these are the traditional birds, but You know, I love YouTube. And so I saw someone that made some ducks and he had the artwork available. So I imported it, the STL file, didn't quite get it right, but here's my little ducks to go. And while these won't be good as giveaways because of the beak, these could be possibly for the gathering of the guilds. So, but the next go around, when I do try to do some ducks, I'll try to make a better beak. So,
Do they do a good job swimming?
quack, quack.
Tracy, can I add something here?
Yes,
I want you to know that your idea of making the beaks on the birds, the traditional birds as the tab is genius, because when we get down to finishing them, the beaks get smaller. And so the way you've done it, using the beaks as a tab, is really working out well.
and I still have to do quite a bit of sanding to get those down to
Mhm.
that profile. But yes, that looks like a pretty safe profile for kids to handle.
Yeah, but I mean, as far as, finishing them and polishing them, then, the beaks get smaller through that process. Just as a matter of the production. So, leaving them slightly bigger is helpful. So, it's working out well. I just wanted to let you know that.
Thank you. Thank you. Now, are you able to zoom in on this? Hang on.
Yeah.
Okay, so my daughter and I have been working on a project for over a year. But this is a piece of black walnut that we got from Gobi. Originally, it was 5 1/4 inches thick. It's about 4 foot 4 inches, something like that, as far as in length. It just barely fits on my table width-wise. It overhangs, but it doesn't run into the gantry, thank God. But this is the back side, and if you notice, it has some bow ties in there. And I don't know what order I have these pictures in, so we'll just, that's the other side. Anyway, what we've done is we carved in using the CNC. First off, I used the CNC to take off 2 1/4 inches of material.
Oh my.
Because this is a coffee table for a chiropractic office where my daughter works. And the gentleman is actually going to make, he's one of the chiropractors, he's going to make the legs. But he didn't want it, 5+ inches thick because it would just be way too heavy. So I thinned it out, having to watch out for twisting and warping in these things as they're so big, But we carved in, well, first off, there were some cracks. So she carved in there by hand and filled with epoxy. I don't know if you can see the areas here where she's filled in some areas, that's fine. And then I carved in the branch and also the leaves. And then she has filled those in with epoxy. So now I have put 3 layers of Osmo oil on the top, and thus far 1 layer on the bottom, because you have to seal the whole thing. So you do the bottom, flip it over, and make sure you don't screw that up, but seal the rest of it, finish the top. It's now cured for 3 days, and so tomorrow we'll flip it over and put 1 or 2 more coats on the bottom. So there's 2 different patterns on the on the branches. So these are supposed to be cherries and supposed to be like a fall atmosphere as far as the leaves and everything else. So that's what's been taking up a lot of room in my shop. So, because every time this gets on on the actual router, I can't do anything because I have to leave it in position. So anyway. Yes, that's another one that I had to add because it started to split a little bit more. When we originally, the two ends were left and we didn't want to cut those until after we got everything more or less done. And so as soon as I put the saw on there, got about halfway through, there was a boink, and the board actually came up about an inch. So with a twist, we finished cutting it off. We saw the crack. We filled it with a little bit more epoxy, and then I put a bow tie there on the top. So there's one bow tie on the top and then 5 bow ties on the bottom. So, and the bow ties are about a 1/4 inch thick. Well, fortunately, the main board did not. It did not twist. So although I'll tell you, the tension's in there. And I've watched a lot of Blacktail. I don't know if you've watched Blacktail at all. One of the things that he does, he puts a channel iron in there to really secure the on the bottom. And I'm going to make that recommendation because it's easy. Just flip it over. We'll put enough room to put a recessed channel iron in. He uses metal inserts to drive the screws in. But that's going to be up to her boss as far as whether he wants that done or not. Because if it doesn't get done before it twists, too late.
Okay. Thanks, Tracy. Okay. I believe, do we have anything else other than Vince's presentation and demonstration? With this, go ahead and if you can put the mic on.
Wow, okay.
I will turn the floor over to Mr. Dovetail.
I've got. Can you, yeah, okay. So a couple years ago, I got a Maverick CNC and wanted to do, among other things, some dovetails. And I wasn't able to find decent software for doing dovetails. I didn't look real hard, but Legacy had some old videos, but they lost them. So anyway, after a career of developing software, I decided to make my own dovetail gadget, which is an extension to VCarve. So I ended up doing what I want. One of my main goals was to be able to do types of dovetails that don't look like machine cut dovetails. And this is an example of that. Of course, you got to get them apart if you want to look at them. Anyway, okay. Yeah.
So hand cut dovetails typically look like this with very narrow pins and wide tails. But I was able to find a way to do this on the CNC. This one has a little bit of requiring a little bit of hand chiseling in the corners. But I also have all kinds of other dovetails. This is the usual half blind that fits in like this, and half blind with rabbit, and then sliding dovetails and through dovetails. I've even got full blind and special decorative dovetails. So how do you use this thing and what can it do for you? Yeah, let's go back to the VCarve screen. So what I've got here in VCarve is a top view of a piece of wood, 3/4 thick and 6 inches long. So if I want to make some dovetails, this gadgets menu, can you see that? Yeah, that's visible. Corbin's Pro Dovetail Maker version 1.2. Click on that. And I can store up to 5 sets of options. This particular thing I've been playing with is number 3. So it brings up a menu, and at the very top, there's a drop-down box for 9 different kinds of dovetails. Box joint, the usual through dovetail, both cut vertically. VV is my notation for the pin board cut vertically and the tailboard cut vertically. Then I've got some variations of some of this funny stuff with pin board cut vertically, tailboard cut horizontally, and that with rounding, and then half blind dovetail with the traditional version has the pinboard cut horizontally and the tailboard cut vertically. Then I've got a couple of other different versions here, a full blind and the sliding dovetail. So here we're going to take a little closer look at the through dovetail. You enter the material width here, it's 6 inches. Thickness, tailboard and pinboard can be different thicknesses. No reason they have to be the same. This is 3/4. I want an angle of 8 degrees. I'm going to use a dovetail bit where the end is 1/2 inch. And the cutting height is 7/8. For rough out and other parts, I need a end mill for the pin board where I'm specifying a 1/4 inch, for the tailboard a 1/4 inch. The combination of these bit sizes and angles determines what the minimum pin width is, which is what makes things really nice if you can get a very thin pin width. when you make a dovetail, typically the parts stick out on each side a little bit. I call that the protrusion. And you can set that to anything you want. I've set it to 30 thousandths here. And you can adjust joint tightness. What this does, it adds this amount to the thickness of the pin on the pin board. The pin board, it doesn't touch the tailboard. But if you add a negative number, you end up reducing the size of the pin. So somewhere from 2 to 4 to 6 thousandths of an inch works pretty well. Now, a big problem with dovetails, especially with using the lead jig, is tear out. I have a lead jig and I've made a lot of dovetails with it, and it drives me crazy because I cannot control the tear out. So I've got two methods of controlling tear out. One, it works for vertical edges, like on the pin board. It will drill down the corners of those pin board pockets. The other option is to use backer boards, and you can have a different thickness backer board in front and in back, or zero. Either one can be zero. Now, I had to make a new update recently because some of my clients were using different machines than the legacy machine, like Laguna machines. And the legacy machine, Maverick, is set up so the vertical vise runs along the y-axis. The board and the vertical vise runs along the y-axis. But these machines are set up so the vertical board runs along the x-axis. So I added coordinate transformations for both the vertical vise and for cutting along on the horizontal table. But I'm not going to go into that very much here. So let's look a little bit further. Suppose we want to do a through dovetail. This gives you options particularly relevant to a through dovetail. If you don't specify any of these options, it will go ahead, okay, and click the button on Create the Pin Board. It says you will need to group the pin board pockets and cut them 0.78 deep using a 1/4 inch diameter end mill. So it tells you how to create the tool paths. When I click on this, it creates a set of vectors. This is the default, which what it does is it finds the minimum pin size, and then it makes tails that match that and stretches things so that everything works. You don't have to put up with that. You've got a lot more flexibility here. You can force the number of tails, or you can force the size of the tails. And if you change the number of tails, you can choose to force the pin and tail the same size. Or you can pick one tail and increase the size of it. Now, what good is that? You specify the tail number and how much you want to increase it.
Well, my particular reason for it was in making a jewelry box, you're going to make dovetails and cut a box. Then you're going to slice it through, slice the lid off. But the kerf of that slice will make one set of tails look funny. So I can increase the size of one of the tails by the size of that kerf, and which is just exactly what I want. So let's take a little bit different. Let's go with 4 tails and create the pin board. I should group that, take the other group, and where is it? Let's start over. Okay. So we're going to do 4, create the pin board. And we've got I'm going to, that's a little hard to see. So, okay, these are the pockets on the pin board. Now, one thing that I don't like about it, okay, so each of these pockets represents a tail, and the pins are fairly small. But dovetails typically have a half pin on each end. But for me, that's frequently, especially with box joints, that's really too small, really too thin, not very much strength. So I've got an additional option here that come back in here and is to bloat the end pin. And usually I bloat it 1/8 of an inch, but I'm going to bloat it a little bit bigger, 2.5. So you can see that, okay? So it's increased the size of the end half pin and then reduced the size of all the other pins just a little bit to make it all work. So does I doubt there's much other software that has that kind of options. But let's look at the tail board now. I'm going to, no, let's go up here. Tail board 6. So here's another file, but this is going to be the tail board, which is the same width and height. Bring up the same thing. With the options that I've selected and all the same options. Let's create the tail board. So it tells me group the tail board rough in pocket vectors, cut them 0.78 deep using a 1/4 inch diameter upcut end mill. Okay. tells me then cut a profile 0.78 deep and 0.05 wide and a single pass for the dovetail bit. So what does this look like? It's kind of weird. You've got these pockets. The roughing pockets. And then you've got this path here for the dovetail bit. It's all the way down full depth, one pass. It cuts across, goes up, cuts over and back. It shifts up a little bit to get just the right size, goes up, goes over and back, up, over and back, up, over and back. Now there's other options. If you add backer boards, it'll elongate these paths. Unfortunately, Recarve doesn't understand 3D views of dovetails. Yeah. Although there we go. So what I'm going to do is load the demo version. Okay. If you to really be efficient, you need to cut more than one board at a time. Or pin boards are funny. They are not symmetrical left to right. So I cut them in pairs, mirrored pairs. And this is important because if you're doing anything asymmetrically, like bloating a tail, when you're doing a box, you can't flip the pin board back and forth. You've got to mirror the pin board, okay? And this allows you to mirror the pin board for the other side of the box. See, you want the bloated pin to line up, but the pin board has to be reversed because the tails are going the other way. So the only way to do that right is to make a mirror cut. And some interesting things about this is there's some little circles here where I've clicked in the box that says, okay, let's do the drill down. And you can look at the 3D view of this. Except it doesn't understand cutting the second piece. So this is what you get for the right side. The left side, you won't see that unless I made it double wide. So let's look at what the tailboard would look like. This is a tailboard, 2 tailboards with 2 backer boards, 1/2 inch thick. So I suppose we could cut this. I mean, it's not going to show you anything interesting if you so there's a rough and pass, then the dovetail pass. It's faking it by doing it as a 1/2 inch diameter end mill. So this is the cutting those 2 sets of pairs is what the demo would be, but things just aren't set up there. It's not plugged in. We haven't gotten them arranged. What? But okay, let's look at some of the other things we can do here. I've got a whole, let's go back in there. Suppose you're cutting on a Laguna machine and you need it rotated the other way. Well, this would be the result, okay? You'd see that the board is running along the x-axis. That other, okay. What? X0Y0 is right here. So you both rotate it and you shift it. Okay, rotate and translate. Rotate it about this point and then shift it over by the width of the material. So let's see what else, other kinds of goodies. Except my software understands that. When you sandwich it together, it compensates for that. Okay, here's the origin right here when you cut it vertically. When you sandwich it together, you add another piece over here. But it actually swaps the pieces, because normally the wider part of the tail is on the left side. But if you went up and down, the round bit couldn't maneuver that little sharp corner. So I swapped them, and I can maneuver this corner. And I do something similar with, okay. Oh, okay. Here is a half blind where we've got very thin pins, and we're getting thin pins because the tailboards are going to be cut horizontally, and we're not using a true dovetail bit. We're using like an 1/8 inch end mill. So let me show you what that looks like. Tailboard. Okay, the tailboard here is cut horizontally, and it uses like an 1/8 inch end mill to cut these little things. And then that fits right into the pin board here. So you got those tails, just these little cutouts are cut on the horizontal case. If you were to cut this 2 at a time, double drill down. Double. Okay, in this case, I also flipped them, but I don't need drill downs here because it acts as its own paperboard. So it's cutting a mirrored pair, cutting out these sockets in here. So let's look at sliding dovetails. Pin board. So a sliding dovetail this down here is called pin board. It's a pin board. The tail board here just has one long tail. It slides into this pin board. Let's look. So this is the vector for the tail board. And it's tapered. Okay, there's 2 ways to taper it. One, you can taper it on the left side or the right side. I support both options. Pin board with the left taper looks something like this, where the red is a rough out, and then the black is half for the center of the dovetail bit. Oh, somebody's car. And this green rectangle shows you where the shelf will line up, will end up. Not mine. So if you have multiple shelves here, you can copy and paste this pattern around. Okay, notice there's the taper is on one side. That's this. I call this a left option because the left side is straight. Or you could call it a right taper option. But sliding dovetails are very difficult to do by hand. But this will set up so when that seats, it will seat all the way along the taper and be flush with the front. Rather difficult to do by hand. Horizontal, okay. why do you, okay, I developed a method so you can create these narrow pin dovetails without having to hand chop anything. So it has a rounding option here. This round exactly matches the dovetail bit used on the tailboard. And then if we look at the tailboard, it has a little round that exactly matches the, let's get rid of this thing, exactly matches the diameter of the end mill used on the pin board. And there will actually be a little round cut here from the end mill on the tailboard, but that's compensated for over on the pin board. So see, that's curved right here. So it all fits together perfectly with nice pass this around. These are full depth. It's not a little halfway. Half-line dovetails. You have to chisel out the corners, yes. Yeah. Make the corners in here sharp. Yeah. Half lined and through dovetails. The full blind uses the rounding option, but you don't see it because it's inside a full blind joint. That's this thing here. So I found a full blind joint in Tag Fried's books and followed that idea. It's got a little, of course, a little miter here, which requires having a 1/4 inch diameter 90-degree V-bit, which I didn't happen to have. So I cut one of the sides with a block plane. So this is one side of the full blind. Let's see, what does the tailboard look like? Oh, okay. This is what the other side, which is cut horizontally. So you can see that there's a little section in here that's the miter. And you've got the pins and tails inside the miter. So what else is there to say except to actually use it? There's a lot of options, there's a lot of testing. I mean, 9 different gadgets. And each of those has all these options. You got to test them all. Yeah. I've tested them on the computer, but I have not retested them all on wood yet. So what if okay. Precision of the jig is really important. Precision of finding the exact corner, X0, Y0 is really important. When you have a stack of wood, like 2 tailboards and 2 backer boards, all those need to line up. So this new fixture that just got installed on the Maverick back there seems to solve that problem. It's got a side where you push them against and then a bottom that keeps them all at the right height, and you clamp them all down and save. When I first did this, I put the origin at the outside of the board, but every time you change the board thickness or add a second board, you had to change it. Now I got it on the inside, so you never have to change it. So the origin is always the same place, and I fix that as one of the offsets in Mach 3. I just picked offset 21. So this extension I do sell on my website, corbinwoodworks.com. I've sold a few of them. It's time for me to upgrade it with the latest additions. There's a user manual, 70-page user manual that goes in great detail of all these things and different kinds of joints, how to do. These things require extra manual steps because we're essentially doing 2 joints on top of each other. Anyway, that's the special centerpiece that kind of takes a lot of extra effort to do. So I'd like to make it available here to the guild users. Get this thing up and running and get it on the machine here. So, any other questions? I will be teaching a class.
Set up on the machine side, does that work for all of the different joints? So is it the same offset for all the various different-
The question was, does the origin setup work for all joints? The vertical origin works for all vertical joints. Let's look at the, okay. Pieces cut vertically, that origin will not change. When you cut a horizontal piece, the origin is here. So if you set up some kind of a guide rail here, it could be the same all the time. But otherwise, it's wherever you put this piece.
The board, okay.
Yeah.
Did Vectrix make the plug-in process easy to do, or was it?
They provide some general information, but very little of when you get into trouble. They will not answer any questions. You got to figure it out yourself.
What development?
This is a language called Lua.
Lua.
LUA, it's Portuguese for pig. It was developed in Brazil, and it's an interpreted language, so you don't have to compile it. And
Blue, a choice you made or a choice Vectrix made?
it's a Vectrix choice, yes. Everything has to be in Lua. Yeah, and then they use some HTML for the interface. Is what? It's very similar to JavaScript, those kinds of languages. It's a object-oriented, fairly simple language with some really weird features. But you can avoid using most of the weird features. Yeah. Okay.
You want to kind of show off the jig?
Yeah,
I know it's
let's
not-
do that.
The whole thing's not working, but maybe that would be interesting, I think. Yeah.
The machine is all unplugged. Do we have to set the origins? Okay. So I'll kind of describe the jig here. So this is the piece you're going to cut on. Okay, you can cut one piece that has depth stops so that if you cut in more than one, you can always, and they're all the same length. You don't have to reset your Z0. This has a couple of knobs on the T-tracks, move up and down. I'll put two of them in here. Clamp it down. That's not going to move anywhere. Now, I made this just big enough to 2 3/4 with 2 back bullets. Very clean. The backer board gives a clean cut on all the edges, even the horizontal ones. Yeah, so it's just beautiful. Just beautiful. So. And the 0 is right there on this corner and it stays there.
Is the 0 there on the back of the board or is it on the first piece?
No, it's the inside of this fixture.
Okay.
So it always stays the same. Yeah. So the software knows that backer board's there. You told it how thick it was. And you need to be precise in how thick it is. And how thick the boards are. And how, if you really want the boards to line up after you flip them around and make a box, you need to be accurate on how the width of the board too. So, yeah, I milled these things to within 5 thousandths. Yeah. Well, I wish I could demo it, but, okay, for pin boards, it'll cut down and demonstrate the drill downs, and then it cuts out the pockets. Now with the tailboard, it cuts some roughing cuts, and then it brings the dovetail bit down and runs it back and forth. Takes 7 minutes per cut, per double cut. Yeah. So 28 minutes for a box. Okay. Yeah. Now, if I knew I didn't have to do the demo, I wouldn't have driven home. Yeah, I guess we had a problem here with the plate is slightly different. You're kidding.
Mine was a real early version of.
Oh, really?
Yeah.
Oh,
So in this case, not only is the pin a different size, but the positioning.
A little bit off. Yeah.
Drill pins into this.
so the holes are one side is in the wrong place.
Well, depends upon whose point of view you're talking about.
Okay. So mine's a newer machine. Yeah, that's the issue. So I downloaded a PCAR file for the plate layout. But apparently that's only for the latest machine. Oh, yeah, okay, yeah.
Just specify exactly what the diameter is,
Or give them a VCAR file.
or that.
Yeah.
That would work too.
And you set your Z0 right here.
So it really doesn't matter how high it really is, well, within reason. But it doesn't have.
I set it up high enough that it's not going to cut into this back side here.
Yeah.
And it's not quite high enough there.
You have to hit the backer boards, or do you have to turn it on?
If I'm cutting the exact same cut, I will reuse them. If it's different at all, I'll flip it around. Yeah, yeah, yeah. It does the job. Yeah, yeah. Yeah.
Yeah.
I had a kind of a crude one, and then after using that quite a bit, I improved it.
This is really awesome. You know, so if the pins had lined up, it would have been a lot easier. But-
Yeah, I expected it to be just like mine.
Yeah.
Yeah,
So,
okay.
all right. Does it make a lot of difference on the board at the bottom that it be exactly level, or doesn't seem like it, since you're really lining up the edge against the side? No, well, no, with a little meter, you know.
This has to be horizontal to your,
Right,
uh,
to the gantry.
yeah. So this needs to be vertical to your spoil wood,
Right.
and so does this. Yeah.
Thank you.
Welcome.
Thank you very much.
Thank you. Vince. Okay, well, thank you everyone for coming. Hopefully we've all gotten something out of the meeting. I got a call from a lady that had bought an Explorer, which is the smaller machine, about the same time that I bought mine. And she wants to sell it, wants to get rid of it. So I thought if anybody is at all interested in one of those, I don't know what she would be willing to take. The machine originally was in the $4,000 to $5,000 range. That's been like 10 or so years ago. I don't know what she would take for it, but it really is a very good, solid machine. I was talking to Mark about his machine that uses a belt drive, and he's thinking that it is not very exacting because of dirt getting into the little teeth. And anyway, this one is very accurate. Just if anybody is at all interested, just send me an email and I'll connect you with this gal. She wants to get rid of her machine. Doesn't have room for it anymore and hasn't used it for quite a while. So, yeah, yes. Yeah, actually, her name has changed a bit. I don't know what the deal is with that, but whatever. I'll connect you with whatever her name is now. So, just curious, obviously for our two people who are brand new to the CNC, has this been valuable to you? I'm just curious. Okay. Right. Yeah, it's a secret. Amazing. Yeah. And Vectric has a ton of different gadgets for doing resizing a bunch of circles or just all kinds of different things. Yeah, textures, just a bunch of different gadgets that people have written. Neat. Yeah, basically, it's a matter of downloading a trial version of VCarve, but it needs to be the 11.0 as opposed to the newer 11.5. Otherwise, it won't work. And we've got a license key that, yeah.
basic instructions you will find. I'm sorry, should I say all that again? So the question was, the comment was that this community has more or less standardized on Vectric products, VCarve in particular, which is largely true. How do you get in with the makerspace version was the question. And the answer to that is go to the class enrollment page on the Shop Guild calendar for this coming Saturday for the intro class. And there you'll find the link for downloading the proper version of VCarve, and then bring your laptop in here to the guild. Craig or one of the other folks has the license code on a thumb drive. You plug that into your laptop and you're in business. But you don't need the code in order to start designing. You'll only need the code when you come in to start actually cutting a piece of work.
Because the way that it works is you have a trial version, but that key needs to be the same as our maker version on our machine. And that's how they can, when you bring it in, then you can run it on. You can create the toolpaths, you can't save them. You can't save them as G code. So that's the piece that you can't use that file. You bring your, and we load it onto the maker space PC. And then that way, then we can carve. So that's the whole maker. That's Vectric's maker version, and it works really, really well. And also, once you load it on here, you can save it, and that's a real version that can basically be taken anywhere. I don't know that Vectric really would like that, but yeah, okay, yeah, yeah. But that's the way that it works, and that way you can design to your heart's content, bring it in here, and it can be carved. Guild. You know, it's there's a variety of different people that have been in the user group for a long while, and for the most part, most of them have several of them have used other software, and that's okay. It really doesn't matter what software. Ian, who's one of us, he helps us, and he's one of our mentors. He uses other software. It's fine. We have to standardize on something for teaching so that everybody with all the laptops is on the same page, if you will. But one of the things for the class, Rich has really done a great job of documenting. So there's I don't know how many page, 70, whatever, just this really thick manual on step by step, you know, follow the directions on each page, and you'll get to where you need to be for whatever you're designing. So it's really a great deal. And for the class, one of the things, we have a 1-to-1 ratio of a mentor working with each student. We have, so far, we've had 4 students per class. So, Tracy. If you haven't, it's too late. So, yes. When we come to our SIG meetings, it's really important for us to log in. And, but if you logged in, fine. If you haven't, you'll be logged out. Good night, Zoom folks. Thank you for attending. We appreciate you coming. And thank you to the bird lady and everybody else. We are done unless there's any questions at all. So